All right, hello and welcome back. So we're going to continue our discrete math discussion. And now we're going to discuss counting and the multiplication rule. So counting is a really big part of discrete math, and the multiplication rule, which is something we're going to be focusing on for most of this video, is a very important tool in counting procedures. So as we learn more complex ways of counting, this multiplication rule will come in really handy. So it's important to get a good grasp of it and understand what it does and when we can use it. Let's jump into it. So we'll start with a theorem. Doesn't really have anything to do with the multiplication rule, but it's a nice little theorem. If we have m and n, which are integers, and m is less than or equal to n, then there are n minus m plus 1 integers from m to n inclusive. So if we're asked this simple question, how many integers are there between 3 and 10, we'll just use the formula. 10 minus 3 plus 1 is equal to 8. Makes sense. So it's just a nice little theorem. I'll give a very brief explanation. The way I like to think about this is we take our two numbers, in this case 3 and 10, and we look at the larger number, 10. And we're thinking about integers. So start at 10 and work our way downwards. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, and so on. Then we consider the smaller number, in this case 3. So we can start at 3, 2, 1, 0, -1. So we start with these black numbers, and we're removing all of the red ones. Kind of. We're removing all of them except 1, because we want to include 3 in this boundary, from 3 to 10 inclusive. So we do 10 minus 3, which would get rid of all of these values. And actually, let me just get rid of the negatives in this case. It's easier to think about it when it's just only positive. So 10 minus 3 gets rid of all of these values here. And then we add 1 because we want to, in fact, keep the number 3. So we only get rid of those values less than 3. It's not the best visual, I'll admit that, but it's sort of the way I imagine it. So if you're a visual learner, maybe that was helpful. But yeah, I mean, the thing to know is just the formula, n minus m plus 1. Cool. Let's move on. So now we'll talk about the multiplication rule, abbreviated MR. So if I say MR, it's multiplication rule. And typically when we do counting, we try to utilize counting in different ways. So sometimes we're given a procedure, and it can be a really complex procedure. But if we can break it down into steps and use the multiplication rule, it turns out to be a really simple process. So let's say we have a procedure that can be broken down into k steps. And say the first step can be performed in n1 ways, and the second step can be performed in n2 ways, regardless of how the first step was performed. And then the kth step can be performed in n sub k ways, depending on how many ways the previous steps were formed. Then the entire procedure can be performed in just the product of those many ways. So if you think about in the last video when we were describing subsets, how to create a subset, we said we look at each element and say yes or no. There's 2 options for each element. We multiply 2 that many times, we get 2 to the power of the cardinality of s. That's how many subsets there are. That's using the multiplication rule. The first step is saying that include the first element or not, 2 ways. Second step, include the second element or not, 2 ways, and so on until we get to the kth element. And then we multiply those 2's together. So that's just the multiplication rule in use. And yeah, MR can be used to break down a multi-step procedure, so it really simplifies the process. And the number of ways to perform each step must be constant, regardless of actions taken in prior steps. So we don't want this n2 to be changing depending on how the first step was performed. So the key thing here is like how the previous things were performed. we can take the previous steps into account when determining what this value of n2 is, or nk or whatever it is. We should be mindful of the previous steps, but our value should be a constant. I may have made it a little complex, but we'll see it in some examples. So let's take a look at an example. Good lead in. Okay, so recall the Cartesian product, which we talked about in the last video. So if we have two sets A and B, then the Cartesian product, A cross B, is the set of all ordered pairs where A is in A and B is in B. So let's just say the cardinality of A is M and the cardinality of B is N. And we're asked to find what is the cardinality of A cross B. We'll use the multiplication rule. And simply, we're going to construct these pairs A comma B and see how many there are. So the first step would be to choose the first member of the pair from set A, right? Find that value. And then the second step is assign a value to the second element of the pair. Cool. So step 1 can be done in m ways since the size of A is m, and step 2 can be done in n ways since the cardinality of B is n. So we'll just use the multiplication rule. We get m times n possible pairs A comma B. So that means the cardinality of A cross B is m times n. So a simple two-step procedures, but we broke down the procedure into those steps and then figured out how many ways can we perform each of those steps and then just simply multiplied them. So a really simple process here. Let's take a look at a slightly more complex example. So we have a sandwich shop. I love sandwiches. They offer a choice of 3 kinds of bread, 5 types of cheese, and 4 types of vegetables. How many different kinds of sandwiches are available? We'll just assume that we need bread, cheese, or 1 bread, 1 cheese, 1 vegetable to make a sandwich, right? So that's the assumption we'll make. And we'll use the multiplication rule again. So we're going to construct a sandwich, one of my favorite things to do. So if you've ever been to a sandwich shop, maybe like Subway or whatever, think about how you do it. First, you choose the bread, right? You tell them I want white bread or whatever bread suits your fancy. So that'll be the first thing that you do. Then they ask you what kind of cheese do you want, so you choose the cheese that you want. And then finally you're just going to choose 1 vegetable because, I don't know, the sandwich shop is weird. But yeah, they offer you the vegetables and then you choose your vegetable. Right? That is the process you go through when ordering a sandwich, and that's how we count how many sandwiches are available. So step 1, how many ways can we choose the bread? Well, there's 3 types of bread available, so it can be performed in 3 ways. Step 2, choosing the cheese. There are 5 cheeses available, so it can be performed in 5 ways. It's important to think, is 5 actually the answer for step 2? And the way that that number could change is if the previous step made this value of 5 less or more. So does choosing the bread affect how many cheeses are available? No. So there still is only 5 ways to choose the cheese. Finally, choose the vegetable. Does choosing the bread and cheese affect how many vegetables are available? No. And there are 4 vegetables available, so step 3 should be able to be performed in 4 ways. So we use the multiplication rule. 3 times 5 times 4 is 60. That's how many sandwiches are possible. Nice. Now let's do an example from scratch. So license plates in the state of Pennsylvania consist of 7 characters. The first 3 characters are letters, not necessarily distinct. The last 4 characters are digits, 0 to 9, and not necessarily distinct. How many possible PA license plates can be made? So for example, we can have like AFX 2, 3, 4, 1. We can have BBQ 0, 0, 9, 9, or wait, BBQ, I just realized that. Or we can have like CAT 3, 1, 4, 1, right? Just some examples there. So, I mean, these are 7 characters. It seems like a daunting procedure, but we can break down the procedure into smaller steps and then count those steps. So what would step 1 be? Step 1. Well, why don't we just work with the first character? So choose letter for first character. How do you spell character? Is that how you spell character? No, there's no H there. Whoops. That's embarrassing. Oh well. Okay, so we'll worry about how many ways to do that in just a moment. What would be the second step? Well, in my mind, I would move on to the second character. So we'll choose letter for second character. And then we can repeat that process for steps 3 and 4 because we need to have 4 letters, right? That's the thing that we're given. And then what happens in step 5? Then we move on to digits, right? So that's a little bit different. So let's specify that. Choose digit for fifth character. And then steps 6 and 7, and there's only 7 steps because the license plate only has 7 characters to it. They follow similarly because they're also only digits. So now we have to figure out how many ways can we perform each step. So let's look at step 1. We choose a letter for the first character. There are 26 English letters. We'll just assume that we're using English letters. So we can do that in 26 ways. Second step, we choose a letter for the second character. There are 26 letters. We have to think, does that number change depending on how we chose the first character? And it does not, because these letters need not be distinct. It specifies it here. They're not necessarily distinct. We can repeat letters, so there's still 26 choices. Similarly, for the third character, there's 26, and for the fourth, there's 26. Next, we move on to the fifth character. Now we're dealing with digits. Actually, I kind of messed this up a little bit. The letters are, there's only 3 letters and 4 digits. Okay, let me rewrite this. Okay, so we're gonna choose, this should be choose a digit for fourth position, fourth character. Okay, so now let's deal with it. We choose a digit for the fourth character. How many digits are there? 0 to 9. Well, there's 10 of them. We can actually use that formula from before, that n minus m plus 1. N minus m plus 1, in this case, n is equal to 9, m is equal to 0, plus 1 gives us 10 values in that range. So there's 10 choices for this, because choosing the digit does not, or none of the previous steps depends on how we choose this digit. Like, there's no dependencies, so it's still 10. Fifth character, also 10 choices, because it doesn't depend on any of the previous steps. Sixth, also 10. Seventh, also 10. So we just use the multiplication rule. By MR, we have 26 times 26 times 26 times 10 times 10 times 10 times 10, and we'll just abbreviate this, 26 cubed times 10 to the 4th possible plates. And that's our answer. So that's why MR is really cool. Just simplify a procedure into its steps and then compute the amount of ways to do each step. And then multiply. Pretty simple. Here's another example. So we're dealing with a pin now, and this contains a sequence of any 4 symbols from the 26 letters in the alphabet and the 10 digits. How many 4-digit pins are possible if no character is allowed to appear more than once? So this is it's kind of similar to the previous problem. Let's just write out some examples. So they're 4 characters long, and they can be alphanumeric. So A7BX 3152 FLMN M12P. How about this one? PQQ2. Is that a valid pin? No, because no character is allowed to appear more than once, and we have 2 Qs, so that's not an example. All right, so how are we going to do this? You probably guessed it. We're going to use multiplication rule, and we'll break it down into steps. So step 1 will probably be choose first character, right? And then step 2 will be choosing the second. Step 3 will be choosing the third. Step 4 will be choosing the fourth, right? And then everything else just follows, and we're just going to count how many ways can we do each step. So, choosing the first character. It can be any of the digits or the letters. So there's 26 letters and 10 digits, so that gives us 36 options. Second one. Now it's a little bit different. In the previous example, we would have said, oh, it's still 36, but now it's different. The reason is because no character is allowed to appear more than once. So while there are 36 possible symbols that could be in the second position, we can't say that there's 36 options for the second position because that value depends on what we chose in the first position. So here, for example, if we assigned A to the first position, this second position, we know it can't be A. So there's only 35 other possibilities for it to be. But that doesn't mean that A doesn't appear in the second position at all. We could, for example, have BA7X. That's valid as well. The main thing is that this second position depends on the first one. So there's 35 ways to do the second step. And notice how this is constant. It will always be only 35 ways to perform that second step because it depends on what we chose for the first character. The third character, that depends on the previous 2 characters. The first and second character can't repeat, so there's 2 forbidden characters that we can't put in the third position. So that means there's 36 minus those 2, 34 options here. And then for the fourth one, there's 33. So then again, we can use by the multiplication rule, we get 36 times 35 times 34 times 33 possible pins. That's not an N. Now briefly, what if this restriction of no character allowed to appear more than once, what if that restriction wasn't there, where any character could appear as many times as we wanted? What would the answer be? Well, I encourage you to try it out yourself, but the answer will be 36 to the power of 4. And the only difference is that these values would all be 36, because now they don't depend on what was chosen previously. All right, but yeah, in this case, that's our answer. One more problem. How many odd numbers between 1000 and 9999 have distinct digits? So let's take a look at some examples. So we have like 6, 7, 3, 1, 4, 2, 0, 3, 1, 2, 3, 5, 9, 8, 2, 7, right? And then let's do a couple of non-examples. So this would be something like 1, 3, 7, 6, because that's not odd. 0, 1, 2, 3, because that's not in our range. 1, 4, 4, 7, because that has an element or a digit that repeats, so they're not all distinct. And let's do one more, like 9, 1, 3, 3. Again, the distinct quality. Okay, so you're probably thinking we need the multiplication rule, and we will use the multiplication rule. So let's try it. Step 1. Let's say step 1 we choose the first digit. Choose first. I hate writing this, but you get the point. And then step 3, we'll be choosing the third. Step 4, we'll be choosing the fourth. And there's only 4 digits to choose from. Okay, so the first digit here. How many ways are there to choose that? Well, we have digits 0 through 9. There's 10 of those digits. But we have to be careful because the first digit can't be a 0 because that would put us outside of our range. So we would say that there's 9 ways to choose the first digit. Okay? Move on to the second digit. Let me just actually write out what these digits are. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Those are our choices. So now our second digit, now there's 10 options, right? The second digit can be a 0. We don't have that restriction, but we know it can't be the same as the first digit, right? Because we need them to be distinct. So we have 10 options, we subtract 1, so there's 9 options here. Third choice. There's 10 options to choose from, but we have to subtract 2 this time because we can't use the digit in the first and second position. So there's 8 choices here. And now we think about the fourth digit. We have to be careful here because we're dealing with odd numbers. So for a number to be odd, its last digit must be odd. So how many odd digits are there? Well, there's 1, 3, 5, 7, 9. There's 5 of them. But wait a second. If we use the multiplication rule here and we get 9 times 9 times 8 times 5, that's not the right answer. The reason for that is because this 5, it's not necessarily always going to be 5. It could fluctuate, right? We came up with this 5 because there were 5 odd digits, but we failed to take into account if any of the previous digits were odd. If they were odd, let's say the first digit was odd, but then these two were even, then here we would have 4 choices. And if these two were odd and this one was even, then here we would have 3 choices. So this 5 isn't constant, so we can't use MR here. We can't assign this to be 5, so we cross that out. Okay, so now what do we do? Well, we can be a little bit flexible about how we do our steps. So what if we do something a little bit different? What if in step 1 we do the fourth digit? Because that seemed to be quite restrictive. So choose fourth. And then in step 2, we'll go and we'll just work it backwards, right? We'll choose the third. And then in step 3, we'll choose the second. And then step 4, we'll choose the first. Right? And everything else will follow. Let's see what happens here. So now we'll start out. Choosing the fourth, it just has to be an odd digit. There's 5 ways to do that. Choosing the third digit, well, okay, there's 10 digits to choose from. We subtract 1 because we can't use the one that was in the fourth position, so there's 9 choices here. Okay, now the second position, well, there's 10 choices, and then we subtract 2 because of the third and fourth position already being filled, so there's 8 choices here. Now the first position, well, we have 9 options to choose from since we can't include 0, and then we subtract 3 from the 3 positions already filled. So that gives us 6 options. But wait, this is also wrong. It's like, why is this wrong now? Well, let's think about it. How did we come up with this 6? We said that there were 9 choices for the first digit, and then we subtracted a 3 because we didn't want it to be the same as the 3 we had already chosen. But what if this third digit was a 0? Then, well, I mean, just for example, let's say the fourth digit we chose to be a 3, and this one we chose to be a 2. Then here, we shouldn't have 6 choices. We should have 7, because out of these, 3 is in here, so we get rid of 3. 0 is not in here, so we don't worry about it. And 2 is not in here, so we get rid of that. And there's 7 options left. So again, this 6 isn't constant. Now you're like, this is crazy. What are we supposed to do now? So now I'll reveal the secret. Secret is, well, we still use MR, but a good practice when we're doing multiplication rule is to sort of take our steps in order of most restrictive to least restrictive. So here we did a really good job of putting the most restrictive step first by choosing that fourth digit, right? Because we knew it had to be odd. This first digit also has a restriction that it can't be 0, but then these second and third digits, they don't really matter. So let's just rearrange the steps one more time. So let's try it again. Step 1, choose fourth. In step 2, we'll choose the first. In step 3, we'll choose the second, perhaps, and in step 4, we'll choose the third. So we're just rearranging the steps. It's still a valid procedure. We can still construct all of these pins by, or odd numbers by following this procedure. It's just a little counterintuitive. But let's go through it. Choosing the fourth, there's 5 ways to do that because there's 5 odd digits. Choosing the first, well, we have 9 to choose from here, and now we subtract 1 because we know that one of these digits was previously used in the fourth position. So we have to subtract 1. So there's 8 options here. Okay, now we get to the second digit. That can be any of these 10, but we know that 2 of them have already been used for the first and fourth positions. So there's 8 options here. And then for the third digit, it can be any of these 10, but 3 of them have already been used. So that gives us 7 here. And now we've approached the correct answer. So by the multiplication rule, there are 5 times 8 times 8 times 7. And what's that equal to? Oh my god. 64 times 7. Now let's just do it the hard way. 56 times 40. So 2240, I think. Is that right? It's been a while. So that many odd numbers between 1000 and 9999. Main thing to take away here. Do use the multiplication rule. It's really helpful. But when you're doing it, first, make sure you're not over counting. And what I mean by that is make sure the values that you're assigning for each step, how many ways they can be performed, are actually constant. Here we had to get rid of this step because it wasn't constant. Same thing here. But in this, all of the steps were constant. It's always going to be 5 options, 8, 8, 7. And the way to do that is another big takeaway. Order your steps in order from most restrictive to least restrictive. And then hopefully that will reach the right answer. So that concludes this video on the multiplication rule. Very, very important tool. Hopefully you can do some good practice with it, and hopefully this is helpful. Hope you enjoyed, and hope to see you in the next video as well. It's a lot of hope I'm having in these last minutes of this video, but keep on working hard, and good luck. Until next time, take care.